Thanks for joining me. This is Hurricane here, and this time I brought for you the Heisenberg's uncertainty principle. Now, people ask me that why there's a need to study the uncertainty principle given by Heisenberg. I tell them that it is important to note that the importance of uncertainty principle is that we get to know that we cannot determine the velocity and the position of a particle at the same time. Now you might be asking why we would need to determine the position of particle at the same time. You know, like 70-80 years back, they broadly gave a hypothesis that stated that every particle is a wave, and every object has a wave character and a particle nature too. That means we need to define its position and the velocity at the same time. But Heisenberg contradicted it and said that we cannot determine the position and speed of a particle at the same time. If you want to determine the position with great accuracy, then the speed changes or the momentum changes, and if you want to determine the momentum or speed, we cannot determine the position with great accuracy. So we can only choose one of them, not two at the same time. So let's get started, and I'll show you what is the basic equation for uncertainty principle and the experiment to know that we cannot determine the position and the speed of a particle at the same time. So for example, here is an electron. Let me change the color. Okay, so for example, here is the electron. Okay, and this is the path of the electron. This is the path. Okay, you might know from let me draw some more shells here and here. Okay, here too. This is the electron, and these are the shells. We get to know this from the Niels Bohr model. Okay, and here is a microscope. Okay, this is a microscope. It's an electron microscope. Okay, and this is a torch kind of thing, which throws light on it, and the light reflects back on the microscope, and we get to know the position and the speed of the electron. Okay, and it's traveling with this velocity down something here. Okay, this is the current velocity of the electron. Okay, and this is the light falling on the electron. Now let me write it. This is the microscope, and this, sorry for that, actually it's difficult to write with this mouse. And this is the light. Okay, when the light falls on the electron, the reflected image is reflected back to the microscope. Okay, it's reflected back like this. Okay, and we get to know the position and the speed. Now, Heisenberg says that if you want to determine the speed and position, you have to decrease the wavelength. Okay, and so if the wavelength is decreased, that means the frequency will be increased. If the wavelength is short, okay, now you will get to know by this. If the wavelength is less, okay, if the wavelength is less, then the frequency will be high, and if the frequency will be high, the momentum of the photons, now this light has photons in it. Okay, these are some photons which are traveling. The momentum will be high, and when they will strike the electron, they will like move it from its place. In other words, it will displace the electron in other directions, so it will be displaced like this. Displaced. Okay, the electron will be displaced. This is the electron to displace in another direction. Okay, so so we might get, okay, Okay, so this is the case. That means that the position of the particle depends, of this electron depends upon the wavelength of the light. Okay, if the wavelength is short, then the greater is the accuracy. Okay, but the wavelength is short, then the shorter wavelength means higher frequency, and higher frequency means higher energy. Okay, so photon will have higher energy, and when it will strike the electron, it will pass its energy to it, so the energy will be conserved. I hope you know that the energy is neither destroyed nor created, and it will be conserved. Okay, and the electron will displace from its position. Okay, but if we want to determine the speed, okay, if we want to determine the speed, you will need to have a large wavelength light. Okay, if you want to determine the speed, but at the same time, when you increase the wavelength, the accuracy of the position will decrease, and you won't get to know the exact position of the electron in the microscope. So it's very simple. If you want, you can get to know only one thing: the speed or the position. If you want to know the position, then you can't get to know the speed because the electron will displace. It's a bit of confusing, but think of it like this: if you want to know the position, the electron, okay, you need to increase, you need to decrease the wavelength, which will result in higher frequency, higher energy, and the electron will displace, and you won't get to know the speed. Okay? And if you want to know the speed, you will need to have a larger wavelength, which means less frequency, less energy of the photon, so the electron will displace, but at the same time it will result in less accuracy for determining the position of the electron. So he gave an equation which says that delta x, sorry for this type of delta, which is a delta x into delta p is equal to h upon 4 pi. So I hope you know this side. Delta x is position and delta p is the momentum, which is also equal to mass into velocity, and on the right side h is a Planck's constant. Okay, it's a fixed value, and below is the 4 pi. Okay, the pi value is similar, it's constant 3.14. okay, so substituting this, taking delta p as delta mv, we can get this delta x into delta mv is equal to h on 4 pi. Okay, delta mv. So taking it to the other side, this means delta x into delta m, sorry, delta v, okay, as we're determining the position and the speed. So delta x into delta v is equal to h upon 4 pi m. So this is the equation given by Heisenberg. Okay, so this is always fixed. This means that you're going to determine the position and the speed at the same time. Okay, now the m is the mass, which is a Planck's constant, as I told you before. The v is the speed, and x is the position of the particle. I hope you guys liked the explanation, and if you liked it, thank you. Please subscribe, and I will see you in the next upcoming videos. Thank you.